Okay, number 2. 1.0 times 10 to the 3 kilogram car accelerates from rest to a velocity of 15 meters per second in 4 seconds. Calculate the power output in the car. So let's write down what we know. VI equals 0 meters per second. VF equals 15 meters per second. T is equal to 4.0 seconds. And M is equal to 1.0 times 10 to the 3 kilograms. We are looking to find P. So P is equal to W over T. Okay, we can't find W because we don't know force. Okay, but we know this is also equal to delta E over T. Now, what is our change in energy? We're assuming that the car is not going up or down, that it's staying along a horizontal surface, but it is accelerating. So we have a change in EK. Okay? So this is equal to change in EK, since there is no change in EP in this situation. So see how you kind of have to read the situation and then determine what formulas to use. So our first step, number 1, is to find delta EK. Well, that's equal to EKF minus EKI. Well, it told me that my initial velocity is 0, so my initial EK will also be 0. So really I'm finding delta EK is equal to EK of my final. So delta EK is equal to half mv squared, VF specifically, my final velocity. So half times 1.0 times 10 to the 3 kilograms multiplied by 15 meters per second, and you square that value. So your delta EK equals 112,500 joules. So then our second calculation is to go P is equal to delta EK over T. So 112,500 joules, all divided by 4.0 seconds. This is equal to 28125 watts. So now, as your final answer, you have 2 options, unless it tells you to specifically put it in kilowatts or watts. There's 2 correct answers, depending on what units. So we could say this is 2.81 times 10 to the 4 watts. Or we could put this into kilowatts as well. Okay? So to go from watts into kilowatts, you divide by 1,000. So divide by 1,000 to get kilowatts. So you move the decimal place 1, 2, 3, 4. So you have 2.81 kilowatts. What? Or did I do wrong? 1, 2, 3. Oh, you're right. Thank you. Only move it 3 spaces. 28.1. Yeah. So either one. So you'll see in your assignment that some of your answers give it to you in kilowatts, but if you want to put it into watts too, that's fine, as long as the conversion is appropriate. Okay? So moving on to the last one now.